Hello, and welcome to this presentation, Understanding SiriusXM Radio. In this presentation, we'll present a short technical introduction to the SiriusXM radio system, and also explain how SiriusXM radio receivers can be tested using vector signal generators. SiriusXM Radio was formed in 2008 from the merger of two separate satellite radio providers, Sirius Satellite Radio and XM Satellite Radio. SiriusXM offers over 100 high-quality audio channels with a range of genres and formats, and is a subscription-based service that requires a monthly license fee. Note that in addition to audio, the SiriusXM network also offers various types of data services for marine, aviation, weather, and other applications. Receivers are most often installed in automobiles, but home or portable receivers also exist. The coverage area of SiriusXM is primarily the United States, although coverage also extends to Canada, Mexico, and some parts of the Caribbean. You may sometimes hear SiriusXM referred to as satellite radio, but as we'll see in this presentation, signal reception may also be from terrestrial, that is, land-based repeaters. Sirius also offers an IP streaming option, but we won't be covering that delivery mechanism in this presentation. Let's start with a high-level overview of the SiriusXM system. Programming produced at various studios is sent to one of several uplink facilities or sites, where it's transmitted to a group of satellites. These satellites then retransmit these signals to receivers, as well as to a network of terrestrial repeaters, which then retransmit these signals. We'll spend the remainder of this presentation discussing the various elements of this system. All satellites in the SiriusXM constellation are in geostationary orbit, and there are generally 5 active satellites in orbit at any given time. 2 of these satellites are placed in the so-called east orbital slot, and 2 of them are placed in the west orbital slot. Within each orbital slot, one of the satellites transmits at the frequencies used by the pre-merger Sirius network, and one transmits at the pre-merger XM network frequencies. We'll go into more detail on this shortly. The 5th satellite can be used as a replacement or spare for either of these orbital blocks. This east-west arrangement of satellites also allows power to be focused on areas with higher population densities, that is, the east and west coasts of the United States. Having separate orbital blocks also provides spatial diversity. That is, if the view to one block is obscured, the other block will usually still be visible from the ground. Satellites operate as frequency-converting bent pipes. This means that the satellite receives time-domain multiplexed, QPSK-modulated uplink signals at a frequency of approximately 7 GHz, and then repeats these signals back towards the Earth in the 2.3 GHz frequency range. Satellite downlink signals are also received and retransmitted by a terrestrial repeater network. This provides coverage in areas where satellite signals are blocked or degraded, most often in urban environments. At present, there are about 600 terrestrial repeaters in the SiriusXM network, and together they cover about 60% of the population of the United States. These repeaters operate as a single frequency network, which means that they all transmit on the same frequency. Unlike the satellite uplink and downlink signals, the signals transmitted by terrestrial repeaters use a special form of OFDM, or orthogonal frequency division multiplexing. The primary reason for using this type of modulation is that it can minimize the effects of reflections or multipath, which is a very common phenomenon in cities and other urban environments. In the ideal case, a SiriusXM receiver would receive and combine 3 signals, that is, satellite signals from both the east and the west blocks, as well as signals from the terrestrial repeater network. As we just saw, however, in urban areas, the satellite signals are often blocked or obscured by tall buildings. In addition, the relatively strong signals from nearby repeaters can also prevent a receiver from detecting the much weaker signals from satellites. In less dense suburban areas, it's sometimes possible to achieve the ideal scenario of reliably receiving both satellite and repeater signals simultaneously. And since there are few to no repeaters in sparsely populated rural areas, reception in those areas is generally provided entirely from satellites. Let's look more closely at the structure and arrangement of satellite and terrestrial signals. As mentioned earlier, SiriusXM operates in the frequency range of 2320 MHz to 2345 MHz. This range is divided into two sub-bands, the lower one corresponding to the legacy Sirius service, and the upper one corresponding to the legacy XM service. The nature and arrangement of signals is different within each subband. The lower Sirius band has three signals, with the east and west satellite signals being separated by a single terrestrial repeater signal. The upper XM band contains 6 signals divided into two so-called ensembles, designated A and B. Each ensemble carries an identical set of signals, one from each satellite and one terrestrial signal. Having duplicated ensembles helps to provide better spatial diversity and improves overall reception quality and robustness. Before we conclude this presentation, let's briefly discuss how SiriusXM receivers are tested. All SiriusXM receivers must obtain so-called Technical Acceptance 2 or TA2 certification before being marketed and sold. Receiver manufacturers will therefore usually perform pre-TA2 testing before the formal certification process. Vector signal generators are used both in this pre-TA2 testing as well as during more fundamental module integration testing. Typically, a generator produces satellite and/or terrestrial repeater signals using arbitrary waveform or ARB files that contain multiple channels with different encoding parameters. These then are either conducted into the receiver or are radiated into the receiver over the air. Note, too, that some vector signal generators can also add noise or interferers for testing the receiver under challenging propagation conditions. Let's end with a brief summary. SiriusXM Radio is a subscription-based commercial broadcast system that delivers high-quality audio programming to the United States and other parts of North America. SiriusXM radio signals are transmitted on S-band frequencies in the range of 2320 MHz to 2345 MHz. This range consists of two sub-ranges containing different signal types and channels, and this arrangement reflects the pre-merger Sirius Radio and XM radio services. SiriusXM Radio is sometimes referred to as satellite radio, but the system transmits signals not just from satellites, but also from a network of terrestrial repeaters as well. The satellite signals are time division multiplexed QPSK signals, but the terrestrial repeater signals use a special form of coded OFDM, because this modulation scheme has better resistance to the effects of multipath. When developing or testing SiriusXM radios, vector signal generators can be used to create various types of satellite and/or terrestrial signals by means of arbitrary waveform files. This concludes our presentation, Understanding SiriusXM Radio. If you'd like to learn more about other types of broadcast signals, how receivers are tested, or about test and measurement solutions from Rohde & Schwartz, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwartz.com.